types of ionic compounds. So mainly we learned two different types of ionic compounds. Group 1 metal plus non-metal from group 5 to group 7. And transition metal plus non-metals from group 5 to group 7. So today we are going to talk about different types of ions. And these ions are called polyatomic ions. So all the ionic compounds we have learned so far has only one atom in the ion. So like sodium plus oxygen minus. So these are monoatomic ions. So single atom in the ion. So today we are going to learn a different type of ion. Ion always has a net charge. So the difference between those ions and these ions is going to be the number of atoms. So now we have more atoms in the ion. That's why it's called polyatomic. Polyatomic ions, more than one atom. Yeah, more than one atom with a net charge. These are called polyatomic ions. So I'm going to give you only 10 polyatomic ions. Okay. So I highly recommend you to memorize these 10 polyatomic ions. So you have all 10 on the back side of your periodic table, but it is very important to memorize these polyatomic ions by formula, charge, and name. So let me give you the list. So there's only one polyatomic cation. Okay, so it's plus one. Okay, plus one. This is the only polyatomic cation, and its formula is NH4 plus one. Okay, so charge is plus one. So this is the charge. It's plus one. And name is ammonia. Ammonium. Okay, so name is ammonia. Ammonia is a different molecule. Ammonia. So next polyatomic ions are going to be polyatomic anions. These polyatomic anions charge range from -1 to -3. Okay, so -1, -2, -3. Those are the possible charges. And these polyatomic anions contain non-metals like nitrogen, oxygen, hydrogen, phosphorus, sulfur. So those are the non-metals present in these polyatomic ions. The next one going to be OH minus. Okay, so formula is 1 oxygen, 1 hydrogen is the -1 charge. So charge is -1. So if you look at your periodic table, or back side of the periodic table, you can see it's under -1 box. What is the name? Hydroxide. Okay, so you have that in on your periodic table, back side of your periodic table. The next one, NO3 minus. So 1 nitrogen, 3 oxygen with a negative charge. So -1 is charge. The name is nitrate. So the next one, HCO3 minus. Again, charge is -1. This has two names, bicarbonate or hydrogen carbonate. It's a noise space here. It's hydrogen carbonate. Next one, Cn minus, -1, cyanide. ClO4 minus. Charge is -1. Perchlorate. ClO3. Yeah. ClO3 minus, again -1, chlorate. All these negative polyatomic anions have -1 charge. So 6. Okay. Anyone need more time? We have these on slide. You have these polyatomic ions on slide 74. Okay, so those are the 10 polyatomic ions. Okay, so next one is going to be SO4 2 minus. The charge is -2. Name is sulfate. Next one is CO3 2 minus. Charge is -2. Carbonate. And last one is PO4 3 minus. Charge is -3. Phosphate. Yes, I think that makes 10. So I'm not going to give you anything out of those 10 polyatomic ions. Now it's your task to recognize those polyatomic ions in a molecule. Okay. So you should remember those 10 polyatomic ions, and there's only one polyatomic cation, and rest are polyatomic anions. So you can see that information on this slide. A group of atoms with an overall charge or net charge often consists of a nonmetal such as phosphorus, sulfur, carbon, nitrogen, oxygen, hydrogen. They usually have -1 to -3 charges. There's only one for yes, correct. So you have a question?
Yes.
Okay. So usually have charges from -1 to -3. There's only one polyatomic cation which is NH4 plus, and these are the 10 selected polyatomic ions. And there are a lot of polyatomic ions. I picked only 10. Okay. So now we can see there's one polyatomic cation which is NH4 plus. Okay. So last Monday I told you normally ionic compounds start from a metal, but it is possible to start it from this because this is a polyatomic cation. So always cations comes first in the formula. So as an example, we can have an ionic compound with ammonium ion. Okay, so this is an ion, the positive charge ion. So we can get another negative charge like chlorine. Chlorine produces fluoride ion. Okay, so now these two will produce a compound. +1, -1 cancels out. Formula is going to be NH4 here. So this is the polyatomic cation, and negative side is going to be chloride. The name of this compound comes from name of the polyatomic cation, and chlorine becomes chloride. So this is the ammonium polyatomic ion. It's ammonium, chlorine becomes chloride. Ammonium chloride is in it. Okay. So now we have two possibilities for the ionic compound. It can be a metal for this particular polyatomic cation. Now let's go back to the slide 97. So this is going to be our ultimate flow chart, which you are going to get in the exam. Slide 97. So when you name a compound, first we are going to decide whether it's ionic or molecular. So molecular, we didn't learn it yet. So it's going to be ionic. If it is ionic, it starts from a metal or ammonium polyatomic cation. Then we are going to follow the rules. Okay, so nonmetals also has two choices now. So we have nonmetals, monoatomic nonmetals from group 5A to 7A, like oxygen, chloride, bromide, sulfide. And also we have a lot of polyatomic anions. Okay, so let's do a few more examples like this. Okay, so let's use barium. And we have polyatomic anion, sulfate, 2 minus. So what is the charge on barium? What is the ion formed by barium? Barium 2 plus, barium group 2. There's only one possible charge on barium, it's always 2 plus. So 2 plus 2 negative cancels out. So there will be an ionic compound like this. Okay, so it's electrically neutral. So this compound is going to be name of the metal, barium. Sulfate. Barium 1R. Barium sulfate. The name comes from the name of the metal, like previous example, and name of the polyatomic ion. Okay, so let's try to make a formula for another compound. This time I'm going to have, let's do something else, magnesium and hydroxide. Magnesium always 2 plus, hydroxide is -1. So hydroxide is a polyatomic anion, charge is -1. So when we write our formula, that formula must be electrically neutral. So in order to neutralize 2 plus charges, we need 2 of these because each has 1 negative. We need 2 from this. So that's what we are going to do the cross multiplication. So magnesium hydroxide. But if you write that 2 like this, it's wrong.
Yeah, it only goes to hydrogen.
Yes, so this 2 belongs to only hydrogen. So don't write it like this because it is wrong. So if you're going to get more than one polyatomic group, it has to be within parentheses. So you're going to group the polyatomic group and write 2 outside of the parentheses like this. So this is the correct way to write it. So if it is more than one polyatomic group in a formula, always group it and put the number outside of the parentheses. So this tells us this molecule has 1 magnesium, so that subscript is 1. So this 2 belongs to both of these atoms in the parentheses. So it has 2 oxygen, 2 hydrogens. Okay. So that's the proper way to write the formula. So what is the name? Magnesium hydroxide. So this is the polyatomic hydroxide. Your goal is to recognize these polyatomic groups. So if you can't recognize those polyatomic groups as a unit, you will have some difficulties in the next chapter because we are going to use these type of molecules with chemical reactions. So when we balance chemical reactions, we are going to identify these units as a single unit. So you're not going to split into oxygen and hydrogen because it's just a single unit. Okay? So let's do another example. Aluminum and sulfate. Okay, so now we are going to find the charge on aluminum, 3 plus. Sulfate is 2 minus. So we are going to write the formula. 2 belongs to aluminum, 3 goes to sulfate. Let's Al2, SO4. Since it is more than 1 polyatomic ion, we are going to write it like that. Aluminum sulfate is Al2SO4 3. 3 is going to be outside like that. The name is aluminum sulfate. Okay, so in this molecule, how many aluminum atoms are in the molecule? Aluminum atoms, how many? Substitute 2. How many sulfur atoms are in the molecule? How many sulfur atoms are in the molecule? This 3 belongs to sulfur, so it's 3 sulfur. It has 2 aluminum, 3 sulfur, and how many oxygen? 4 times 3. Each sulfate has 4 oxygen, and there are 3 units of that sulfate. So 4 times 3 is going to be 12 oxygen. So we are going to multiply by the number outside of the parentheses to get the number of atoms. Okay, so we will use this in the next chapter. So you should be able to count the number of atoms in the molecule. Okay, any question? Name is aluminum sulfate. Again, those metals are from group 1 to group 3. So our metal can be one of the transition metals. So if metal belongs to the transition metal group, then we are going to use the charge of the metal in the name, like this example. Okay, let me see another example here. Let's pick something like cobalt chloride. Okay, so it's not cobalt chloride because cobalt is one of the transition metals. So if it, oh, sorry, that's a bad example. So I need a polyatomic group here. So let's say nitrate, NO3. cobalt 3. Okay, so now we are going to write the formula. So nitrate is -1. So cobalt, nitrate, then this 3 goes out of the parenthesis. So this is -1, so it's 1 cobalt. So since this metal belongs to transition metals group, we're going to use the charge of the transition metal in the name. Cobalt 3 and name of the polyatomic anion is nitrate. It's cobalt 3 nitrate. You're going to follow all the previous rules. Okay, you can't forget those rules because cobalt is one of the transition metals. So that's easy. Again, when I'm giving you the charge of the transition metal, but you're not getting it like that. So you will get your formula like this. So nickel upside. Okay. Now we can see again nickel belongs to transition metals. So we are going to use the charge balance equation and find the charge on the transition metal. So basically we are going to split this into positive and negative. So this is the positive side, this is the negative side. So number of nickel 1, that's the subscript for the metal. Then X, that's the charge, it's variable. Then instead of number of non-metals, it's going to be number of polyatomic ions. So we have 2 hydroxide in formula, and this is the hydroxide rule. So you have this on back side of your periodic table, you can get the charge. So that's -1 equal to 0. Solve for X, X is +2. So if one hydroxide is 1 negative, so total negative on this side is going to be 2 negative. So then this side should be +2 in order to make it neutral. So simply we are going to solve for this value. So if you can split it like this, that's fine. You don't need to do this work. But if you don't know how to split it, you have to use this equation. So use whatever is for you. Now we can name this compound. It's nickel 2 hydroxide. It's nickel 2 hydroxide. Any question? Okay, so let's do more examples because we have finished naming ionic compounds. So those are the only different types of ionic compounds you're going to see. So let me start from another example. So this is a transition metal. There's a sulfate of iron. Okay, so now we are going to name this molecule. So what is the charge on iron in this molecule? What is the charge? Anyone? It's +2. Okay, so the reason is we're going to split this. So now you can see this polyatomic group. That polyatomic group is sulfate. It has 2 negative. So if this side of the molecule is 2 negative, this side should be +2 because it's 1 iron. The sulfate has 2 negative. So to neutralize that sulfate, we need +2 or 9. So that molecule is going to form between Fe2 plus and sulfate 2 minus. 2 to 2 cancels out. Fe is of course the formula. So we are going from here to here. Okay. Again, if you are going to use the charge balance equation to do this, you should be careful because in this case, you are not going to use 4 as the number of anions. If you are going to write the charge balance equation for this molecule, number of ion, subscript is 1. Charge on ion is X plus the number of polyatomic units. So it's 1 sulfate group. So it's not 4. It's just 1 sulfate. And then sulfate is -2 equal to 0. Solve for X. X is +2. So one of the common mistakes is some student will pick the number of polyatomic unit as 4. It's not 4 because that 4 belongs to the polyatomic group. So if it is more than 1 polyatomic group, you will see the parentheses and number outside of the parentheses. Okay. So name is iron 2 sulfate. Name is iron 2 sulfate. Okay. Any question? Okay, so now it's time to do more examples. So there are a lot of examples on my slides. think we finished this one. Slide 78. Did we finish this? Slide 78. We did? Okay. So now you should be able to name all these molecules. So slide 79. Name all these compounds. You can write the formula and name. Write the ionic formula of the compound formed with the following. So you can write the formula and then name it. So you can practice both. Write the formula and name it.
Oh.
What is the name of the first compound? A formula. CaCl2 goes to chlorine, one goes to barium, so it's barium chloride. What is the name of the second compound? You had this in the bonus quiz. 3 goes to aluminum, 2 goes to, sorry, 3 goes to oxygen, 2 goes to aluminum. Al2O3, aluminum oxide. Okay. So, last 3 questions we have learned it today. Calcium with sulfate, you can see +2, -2, 2 to 2 cancels out. So 1 calcium, 1 sulfate, that's the formula. 1 calcium, 1 sulfate. So name comes from those two. That's calcium sulfate. Okay. The next one, 2 polyatomic groups. So one is ammonium, the other one is phosphate. So this 3 goes to ammonium. So we need 3 ammonium and 1 phosphate. The formula is NH4 parenthesis 3 outside of the parenthesis and then phosphate. Name of that molecule comes from the name of the 2 polyatomic ions. So name is ammonium phosphate. Ammonium phosphate. Ammonium phosphate. Last one, there's an error on this slide, so it should be 3 plus, aluminum 3 plus. It was an error. And carbonate 2 minus. So then we can write the formula. Let me write it here. Aluminum always 3 plus. Carbonate is 2 minus. 2 goes to aluminum, so it's Al2. 3 goes to carbonate, since it's more than 1 polyatomic group. we use that number outside of the parenthesis. The name is aluminum carbonate. Aluminum carbonate. Aluminum carbonate is. Okay, so we finished the ionic compounds. So then we are going to talk about acids and binary compounds. So these are the rules of ionic compounds. Wrong direction. Okay, so these are 5 more ionic compounds. So I'll give you 2-3 minutes to name those 5 compounds. Slide 87. And you can follow the flow chart on slide 88. What is the name of the first compound?
Magnesium carbonate.
Magnesium carbonate. Okay, so try to follow this flow chart because you will get this one. This flow chart is the exam. Let's start from a metal. Metal belongs to group 1 to group 3A, or one of those 3. Use the name of the element or ammonia. So if it's a metal, use the name of the element. If not, the other one is ammonia. So this is a metal. It's magnesium. Okay, so then the anion side. Okay, so let's go to the flow chart again. So this is the anion side. Is the nonmetal ion formed from one atom or group of atoms? So that's a group of atoms. We should be able to recognize this as a group of atoms. So if the molecule has more than 2 different types of atoms, definitely there's a polyatomic ion. So that's carbonate. So if it's a group of atoms like this, use the name of the polyatomic ion. Okay, so it's carbonate. Next one, same process. So metal, group 1 to group 3, that's calcium. And this is a group of atom, that's sulfate. So name is calcium sulfate. Next one, lead. Lead is a metal. So let's go to the flow chart again. So now that metal is not from group 1 to group 3 or silver or cadmium. So now it's in this part of the flow chart. So if it belongs to group B or group 4, group 5A metals. So it's a group 4A metal, lead is going to be here. The group 4A metal, then it's a transition metal. So then use the element name followed by Roman numeral equal to the charge. And that's where you need the charge balance equation. So we are going to split this into positive and negative and find the charge on leads. So there are 3 leads. Charge on lead is variable. Then number of polyatomic groups. So in this case, it's 2. And then you should be able to recognize this. So it's on backside of your periodic table. PO4 3 minus, so this is the charge. Negative 3, 0. Then you can solve for x is equal to plus 2. Okay, so that's lead blue phosphate. Name of the metal, immediately charge within parentheses using Roman numerals, and then polyatomic anion name. Again, calcium 1 to group 3, so we don't need the charge. So it's calcium. This is the nitrate group, so calcium nitrate. Last one, again, iron. Iron is a transition metal because it belongs to group B metal. In the flow chart, it goes for this section, transition metal group B. So we are going to split this into positive and negative. So let me write that molecule here. FePO4. Okay. So you can write the charge balance equation. So it's going to be number of ions on charge on ion variable plus number of polyatomic groups. Don't use 4 because it's 1. And phosphate is -3 equal to 0. Okay. So don't use this 4 because we don't have parentheses. So that phosphate is just 1 unit. So we have charge and just 1 unit. So when you solve this equation, x is equal to plus 3, the name is iron 3 phosphate. Okay, if you have correct answers for these 5 questions, you are good. You have learned naming ionic compounds. If not, you have to go over my lectures again and make sure to practice this. Any question? Do you need more examples? If you need more examples, there are 2 worksheets on Blackboard and it has like 100 of examples. You can download those 2 worksheets and practice. Worksheets and study guides, chapter 2, naming compound worksheet 1. It has 35 answers are given below. And it has naming molecular compounds, which we are going to learn now. And also answers are available at the bottom. Second worksheet also has more compounds. Naming ionic compounds, answers. Based on the formula, you can give the, based on the name, you can write the formula. So you have answers at the bottom. Okay, so now we are going to move on to the next type of molecule. So that's going to be molecular compounds. How do we recognize molecular compounds? Based on the type of the elements present in this compound. So this is an example for a molecular compound. Okay. These are examples of molecular compound. So in general, molecular compounds has 2 nonmetals. So these are 2 nonmetals, and because of that, it's called binary molecular compound. So I'm not going to talk about molecular compounds which has more than 2 nonmetals. Okay, so all the molecular compounds which we are going to learn has 2 nonmetals. So that's why it's called binary molecular compound. So molecular compounds also called covalent compounds, molecular compounds. So also called covalent compounds. compounds or covalent compounds formed between two nonmetals or metalloid and a nonmetal. Sometimes it can be a metalloid and a nonmetal, like this example. Silicon is a metalloid and oxygen is a nonmetal. Okay, so how many of you recognize this molecule, CO2? What is that molecule? Carbon, carbon dioxide. You know the name, but you don't know how to name it. So we are going to learn the rules. So this is how we name binary molecular compounds. First non-metal gets its element name. So that's the first rule. First non-metal gets its element name. So this is carbon, carbon. Okay, so same as the name of the element. Second non-metal gets its plus syllable plus I, like ionic compounds. Oxygen become oxide. Okay, so this is the name, carbon dioxide. We have oxide, we have carbon, and we don't have this. So di means number of oxygen atoms in this molecule. So there's a prefix for number of atoms. If it is 2, then prefix is di. Carbon dioxide. So normally if it is 1, we don't use that prefix. Okay, so 1 carbon, we don't use the prefix for 1. If there's a subscript value, if it is more than 1 atom, which means that if there's a subscript, we are going to use the prefix for that particular subscript in the name. Okay. So, but there's one exception, and that exception is this molecule. Did anyone recognize this molecule? CO, carbon monoxide. Okay, so if it is 1 atom, that prefix name is mono. Okay, so now first non-metal gets its element name, so that's carbon. It's 1 oxygen, so that's mono. Oxygen become oxide, and we don't write 2 vowels together, so we omit the first vowel. So when we see A and O and O, we cancel out the first vowel. Okay, so carbon monoxide. So this is the place which we use mono prefix. In all the other places, we don't use the mono prefix, so it's carbon monoxide. So let's practice this. So before that, we need the prefix for each number of atoms. So I'm going to give you 1 to 10 prefixes. Okay, so based on the number of atoms in the molecule, if it is 1 to 10, you will get those prefixes on front page as well. This is the number of atoms. It's going to be the prefix. So we already know the first 2. If it is 1 atom, prefix is mono. If it is 2 atoms, prefix is di. If it is 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, and you heard the other one, 8, oct, octa, octet rule, it's octa, 9, nona, 10, deca. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You don't need to memorize it, and it will be on front page. Okay. So we use prefixes only with molecular compounds. Don't use it with ionic compounds. So when you name a compound, first you are going to divide into molecular or ionic. If it is ionic, follow the ionic rules. If it is molecular, follow the molecular rules. So now let's use these prefixes and name different molecules. Okay, so NCl3, nitrogen, chlorine, both are non-metals. So it's going to be molecular. What is the name? First non-metal gets its element name, nitrogen. Then it is more than 1 atom. So 3, what is the prefix? Tri. Chlorine become chloride. Nitrogen trichloride is in it. Nitrogen trichloride. CCl4. What is in it? Carbon tetrachloride. Carbon tetrachloride. Carbon tetra is the number of chlorine chloride. Okay. N2O3. Okay, so now we have more than one atom here. So we are going to use the prefix. What is the prefix for two? Di. First non-metal is nitrogen. Dinitrogen. Three is tri. Oxygen become oxide. Trioxide. Trioxide. So dinitrogen trioxide. Any question? Let's do more. E2O5. What is the name?
Diphosphorus.
Diphosphorus. 5 is penta oxide, pentoxide. Diphosphorus. Pentoxide. Cancel the first row. Pentoxide. Diphosphorus pentoxide. CL5. Phosphorus pentachloride. The naming covalent compounds easy. You simply need to give the number of atoms in the name. Okay, so you can see these rules on slide 89. When naming covalent compound, the first nonmetal in the formula is named by its element name. The second nonmetal is named by using the first syllable of its name followed by icon. If a subscript is used in the formula, a prefix is used in front of the name, front of its name. When vowel O and O or A and O appears together, the first vowel is omitted. So you can see the prefix table on this slide, and also you can see the exception. Carbon monoxide is the exception. So there are 7 examples on this slide. So you can see CS2, carbon disulfide, carbon disulfide. So we did the next one, carbon dioxide. Next one is nitrogen oxide, one of nitrogen and one oxide. So it's simply nitrogen oxide. Dinitrogen oxide is the next one. Sulfur dioxide, sulfur dioxide. Sulfur trioxide, and last one, sulfur hexafluoride. Okay. So there are 3 examples in the next slide. So what are the answers? What is the first molecule? Even silicon metalloid, same as the covalent compound. So what is the name? Silicon tetrachloride. So silicon tetrachloride. Answer is 3. Next one, diphosphorus pentoxide. Diphosphorus pentoxide. Answer is 3. Last one,
Dichloride hydroxide.
dichlorine heptoxide. Dichlorine heptoxide. Dichlorine heptoxide. Answer is 8. Okay. Write the name of each covalent compound. What is the first one? Carbon monoxide. So that's the only exception. You need to use mono. Carbon monoxide. So we have monoxide. Next one. Nitrogen dioxide. Next one. Phosphorus trifluoride. Last one we did it. So carbon tetrachloride. Carbon tetrachloride. Again, based on the formula, based on the name, we can write the correct formula. So phosphorus pentachloride. So there's one phosphorus, and there are 5 fluorine. PCl5 is the formula. The next one, dinitrogen trioxide. So there are 2 nitrogens, dinitrogen trioxide, and there are 3 oxygens in the molecule. N2O3. Sulfur hexafluoride. So yes, hexa means 6. There are 6 fluorine and 1 sulfur in the formula. Okay, so now you can see the complete flow chart. Name, molecular compounds, and ionic compounds. The first step, decide whether ionic or molecular, and follow the molecular rule. I think ionic compounds. Okay, so what is the name of this compound? What is the name of BaCl2? Barium dichloride. Any different answers? Is it ionic or covalent? Is it ionic or covalent? Ionic. It's ionic. So no prefixes with ionic compound. It's simply barium chloride, no di. So it's just barium chloride. No prefixes with the ionic compounds. So you have to decide whether it's ionic or covalent. So that's the first step. Decide whether it's ionic or covalent, then follow the appropriate rules. So this slide has ionic compounds and covalent compounds. If you can name all these 5 compounds, you're really good. You can proud it, and you have learned. If not, you have to go over again my lecture slides. I'll give you 5 minutes to name those compounds. Would you like to have your quiz on Monday or next Monday? So, next week Monday or week after next?
Is it a bonus or? Is it?
No, it's a in-class quiz. Would you like to have this coming Monday or week after next?
The next one.
Yeah.
Okay.
We have a lot next Monday.
Yeah, you have a lab. So definitely your quiz is going to be during a lab time. So I can give it on 18th September or 25th September. 25th? Okay. It's going to be on 25th. Is everyone agree with 25th? Okay. Then you have enough time, so there will be 25 questions. Molecular compounds, ionic compounds, and we are going to learn acids in 5 minutes. And then you will have your presentation on October 2nd. So that's the date, October 2nd. Element presentation, it's on October 2nd. Get ready for that one. Okay, first one, is it ionic or covalent? First compound. Covalent, what is the name? Sulfur trioxide. Second compound, is it ionic or covalent? Ionic. I already named that compound, so it's barium chloride. This one is sulfur trioxide. This is ionic. This is covalent. Okay, so this is barium chloride. No prefixes in the ionic compound. Next one, ionic or covalent? Ionic. Okay, so when you see more than two atoms in a molecule. For your class, it's always ionic because I didn't teach you any covalent compound with three different elements. So now you have more than three atoms. Yes.
Would that be dots?
No, because this is ionic. Ionic compounds, no prefixes. Okay, so we are following this side. So mainly we talk about these from the last lecture and first part of today's lecture. So we finished this like 10 minutes ago. So that's why we use the prefixes. Only molecular compounds comes with prefixes, and that's this part. So ionic compounds are the difficult part. Okay, so since this is ionic, no prefixes. Next one, ionic, two polyatomic ions. So name comes from the name of the two polyatomic ions. What is the name? Ammonium phosphate. First polyatomic ion is ammonium. Next one is phosphate. Simply it's ammonium phosphate. Next one, ionic or covalent? Ionic. Okay, so now we have a choice. Is it belongs to group 1 metal or group B transition metals? Group 1 to group 3 of transition metal. So copper. Is it a transition metal?
Yes.
Yes. Then you are going to write the charge balance equation and find its charge. So number of copper, 2. Variable charge for copper. This is a polyatomic group, carbonate, and you should be able to find that group and its charge. That's -2. There's only one carbonate equal to 0. So X is equal to +1. So what is the name? Copper 1 carbonate. Copper 1 carbonate. Last one, ionic or covalent. Metal 3 are ionic. What is the last one? Covalent. Both are non-metals. So what is the name? Dinitrogen tetroxide. Tetroxide. Dinitrogen tetroxide. There are two vowels together. We drop the A, tetroxide. Okay. Any question? So you can see answers in the next slide. So now we are going to talk about acids. I'm going to give you only 10 acids. So in the exam, you will see 1, 2 or 3 acids to name. In the quiz, you will get 2 or 3 again. So how do we recognize acids? Normally, acids start from hydrogen. Okay, so acids start from hydrogen. Okay, so it start from hydrogen. So I'm going to give you only 10 acids. So first 5 acids are going to be hydrogen with halogens. So hydrogen with fluorine. Okay, hydrogen and fluorine. This is called hydrofluoric. Hydrofluoric acid. So acid comes with halogen of cyanide polyatomic ion. Okay, so we talk about this polyatomic ion. Cyanide is Cn-1. In order to neutralize this -1, we need 1 hydrogen because hydrogen can be +1. So it's HCl. So acid with halogens or this particular polyatomic ion, HCl, HBr, HI. Okay, so those 5 acids start from hydro. End with ic acid. And the middle part comes from the non-metal. So chlorine becomes chloric acid. Hydrochloric acid, HCl. The next one, hydrobromic acid, hydroiodic acid, hydrocyanic acid. Hydrobromic acid. Hydroiodic acid. Hydrocyanic acid. So there's no space here, no space. So there's a space between acid and the thick part. So these are the 5 acids which start from hydro and end with ic acid. Hydrochloric, hydrochloric, hydrobromic, hydroiodic, hydrocyanic acids. Okay, so next 5 acids comes from hydrogen and polyatomic ions. So I gave you a list of 10 polyatomic ions, and that's another important part of polyatomic ions. Hydrogen H plus with nitrate -1, so it cancels out. So we have an acid HNO3. So these acids, these polyatomic ions are end with 8. Polyatomic ions end with 8. Simply convert into ic acid. No hydro part. So it's simply nitrate transform into nitric acid. So this is the name of the polyatomic ion, nitrate. Nitrate simply transform into ic acid, nitric acid. Next one is H plus with ClO3 minus. This is chlorate with hydrogen, chloric acid. This is chlorate. The next one, we need 2H plus, 2H plus because sulfate is 2 minus. Since it's 2 negative, we need 2H plus. So in the formula, it's going to be H2SO4. Okay, so this is HClO3. HClO3 is chloric acid. Sulfate is 2 negative, so we need 2 hydrogen. So these are called diprotic acid. So when it is more than 1 hydrogen, if it is 2, it's called diprotic. Okay, so sulfuric acid is a diprotic acid. So this is sulfate. Sulfate transformed into sulfuric acid. Next one. Again, we need 2H plus to neutralize carbonate ion. Because carbonate is 2 negative, to cancel out 2 negative, we need 2H plus. So acid is going to be H2CO3. So this is carbonic acid. Polyatomic ions end with 8, simply transform into ic acid. So carbonate, carbonic acid, sulfate, sulfuric, chlorate, chloric, nitrate, nitrate. Last one, we need 3H plus to neutralize phosphate. So it's going to be H3PO4. Phosphate transform into phosphoric acid. Phosphoric acid. Phosphate, phosphoric acid. Since it's 3H plus, it's called triprotic. Triprotic. Protons, same as H plus. So that's why it's called protic. So triprotic means 3H plus in the acid. I think there are 10 acids. So those are the 10 acids that you need to study. So 5 start from hydro. The other 5 doesn't start with hydro. So I explained this part. Acid with a hydrogen and non-metal cyanide ions are named with hydro prefix and end with ic acid. So polyatomic ions end with 8, simply transform into ic acid. So there are 2 examples. And we did not learn this part, so you can ignore that part of the slide. Okay, so there are some other acids. I don't want to put all those acids. Again, you can skip this slide. So probably I think I dropped those from your book. I guess you don't have those. Okay, so I picked only 10 from this slide. So let's quickly go over the answers for these. Okay, so HNO3. So last one, let's transform into HNO3. HBr, what is the name? Hydrobromic. So it starts from hydro. H2CO3, what is the name? Carbonic, no hydro, because it's a polyatomic ion end with 8. So carbonate transform into carbonic acid, no hydro. Next one, HClO3, chlorate transform into chloric acid. Is B. So let's change last one into HNO3 because I didn't give you NO2. So HNO3, nitrate. Nitrate transform into nitrate. Okay, so that's all. So that's the end of chapter 2, and I will start chapter 3 on next Monday. And don't forget your calculators. We will do some calculation in chapter 3.